All right, now we're going to continue with graphs of the trig functions. Let's go back and look at some of the features of these graphs. Let's analyze these graphs a little bit, okay? So what we're going to be looking at, let me just kind of clean up a little bit over here so I have some room to write, is I want to talk about things like domain, the range, maybe x-intercepts, y-intercept, and then I'm going to talk about two other things called period and amplitude in a little bit, okay? So can you see how the sine function continues in both directions, a nice smooth curve, no gaps, no asymptotes? That means the domain is going to be all reals. All right, now, do you see how and remember domain is x's, range deals with what the y coordinates of the points are, and see how this is kind of like going up to 1 and down to -1 and up to 1 and down to -1, but it doesn't ever go above 1 or below -1. Okay? The range is going to be from -1 to 1. All right, when you look at the x-intercepts, you know, see how we have an x-intercept at 0, at pi, at 2 pi, at -pi. Okay, the x-intercepts happen at multiples of pi. So the x-intercepts happen wherever you have n pi, you might say. N pi. And I won't do this on every one, but where n is an integer. So let's just make that agreement. N is going to be an integer. So the x-intercepts happen at n pi, at 0 pi, 1 pi, 2 pi, -1 pi, -2 pi. You're going to have an x-intercept. Right? And then notice the y-intercept happens right there at 0. All right, now remember that y-intercepts and x-intercepts are really points, but a lot of times we just use for the y-intercept, it's the point 0, 0. But a lot of times we just say the y-intercept is 0. And for x-intercepts, if I wrote it as a point, it would be n pi. Let me erase this word, put it over here. It would be n pi 0, but then technically a lot of times we just say the x-intercepts happen at n pi, okay? All right, so what about vertical asymptotes? We don't have any, do we? Don't have any horizontal either, but other trig functions have vertical asymptotes. Asymptotes is asymptotes, but we just don't have any vertical asymptotes. And none of them have horizontal asymptotes, so I don't even ask you about that, okay? All right, now two other vocabulary words I want you to know that are kind of specific to trig functions. One of them is called the period of the graph. Okay, so these trig functions are periodic, and the period is like the length of time it takes for the graph to repeat itself. Okay, so I'm going to do that in blue on this one. So do you see how, you know, we started here at 0? We wouldn't say pi is the period because it's not exactly repeating itself down here. You know, now it goes below. But if we go and we take a copy of this, what I just did in blue, if I copy that and just continue it to the right and continue it to the left, okay, I would wind up having the complete graph. So the period of the sine function is 2 pi. That's how long it takes, okay, what it takes in order to be repeating itself. So the period would be 2 pi. Right now, another word we use a lot with trig functions is called amplitude, okay, and that has to do with how stretched vertically the graph is, how high up it goes, okay? All right, so the amplitude is actually the difference between the x-axis and the highest point, okay? And so it's this. Let me do this in green. I think of it right here. That height is the highest point. So the amplitude is going to be 1. Okay. All right. It's not 2. It's not the difference between the highest and the lowest. It's just this from the x-axis to the highest point. So the amplitude is 1. And we're going to learn later about how to tell what the period and the amplitude are from your equations. So I'm going to go ahead and mention that. The fact that there's an understood 1 out there is why that turns out having an amplitude of 1. Okay. And then the period has to do with going around the unit circle. That's 1 full revolution. It takes an entire revolution in order to get every value of the trig function to show up. Okay. And then that can be repeated. All right, so let's go through this for the others. Okay. So let's think about that with cosine. So be thinking about it. Go ahead and write down what you think they are, and then we'll check and see. Domain and range, x-intercepts, y-intercept. There can only be one y-intercept. Okay, wouldn't be a function if you had more than one. And then let's do those extra words. Let's talk about the period and the amplitude. Okay. All right, so for the domain, again, it's negative to positive infinity, isn't it? The range, again, from -1 to 1. X-intercepts are in a slightly different spot, though. This can be a little bit hard to tell. They're at 1 pi over 2, and then 3 pi over 2, and then 5 pi over 2. So it's a little harder to say generically what that is. That's probably the hardest part, is it's at 1 pi over, they're at, you could list them, pi over 2, okay, 3 pi over 2, 5 pi over 2. See how they're at like the odd ones? Okay. And then at negative pi over 2. So you could talk about them and list them, but it's kind of hard sometimes to write that out formally. So let me list it so that it really makes sense. And it would go in both directions like that, wouldn't it? So here'd be another one. And then you could write it. You could say pi over 2. You could say they're at pi over 2 plus, and see how this right here is pi. Okay, so pi over 2 plus 1 pi would get you to here. Pi over 2 plus 2 pi would get you to here. So it's pi over 2 plus n pi. And then if you took away a pi, you'd be over here. Took away 2 pi, you'd be over here. So that's one way of saying it in general. And remember, all of these could be written as ordered pairs. Okay, you could put a 0 after each of those and create an ordered pair if you want. But the x-intercepts are at pi over 2 plus some integer times pi. All right, the y-intercept here is at 1. Okay, and we could write it as the ordered pair 0, 1. All right, now the period on this is also going to be 2 pi. You really don't get all the values of cosine until you've come all the way to here. Okay, then you see that picture getting repeated over and over and over again. So the period for the cosine is also 2 pi, and the amplitude is also 1. Okay. All right, let's take a look. Oh, and I didn't write them. I didn't consider them because we don't really have them. I could have asked about asymptotes. There just aren't any. Vertical asymptotes, there just aren't any. Okay. All right, let's look at cosecant. So focus on the red graph when we're doing this. And let me see, let me write it down here below. So look, we're going to do domain and range. We're going to do x-intercepts, y-intercept. We're going to talk about vertical asymptotes and where they happen. And then we're going to be talking about, we'll do period. And I'll go ahead and squeeze in amplitude right there. Change to red. Okay, so the domain, remember we're focused on the red ones. There are gaps in the graph. There are no ordered pairs at 0, at pi, at negative pi, at 2 pi. Okay, so we do have gaps in the graph. I'm not going to write it in interval notation because I have to exclude all of these places where we do not have an ordered pair. So let's just say x can be any real number except x can't be at a multiple of pi. And remember, n is just an integer. So x can't be at a multiple of pi. All right, now looking at this, we're looking at what the y values of these points on the red graph are. So what the y values of these points are, okay? So when you're looking at that, your y values can be anywhere from negative infinity until you get to -1, including -1. But then there's a gap. See where the sine graph is located there in the middle? There are no ordered pairs that are part of the cosecant. So you have to jump over that and you pick back up at 1 and go towards positive infinity. So it's like the range is everything but what you had for the sine graph. Okay? Now, let's look at x-intercepts and be careful. Don't focus on cosine, focus on the red graph. I mean, don't focus on, which one are we doing? Cosecant. Okay, don't focus on sine, don't focus on the sine graph you see, focus on the cosecant graph, which is what you see in red. And you see how the red graph never crosses the x-axis? There are none. No x-intercepts, okay? It also doesn't have a y-intercept. Because see how that approaches the y-axis, approaches that vertical intercept, but there's a vertical intercept on the y, a vertical asymptote, a vertical asymptote on the y-axis. So the graph approaches that vertical asymptote, it never hits or crosses the y-axis. So you do not have a y-intercept. All right, now this is the first one we've encountered that actually has vertical asymptotes, and they happen at every multiple of pi. So it's like the domain and vertical asymptotes are related in a way. What you have to exclude from your domain is actually where you have a vertical asymptote. And these vertical asymptotes are vertical lines. And so the vertical asymptotes happen at x equals n pi. X equals a multiple of pi, okay? All right, now let's look at the period. The period for this is also going to be 2 pi. You know, pi only gets you this top part. You also need the bottom part. You need both of those parts, and then you can start repeating in both directions. So the period is going to be 2 pi. The amplitude on this, we usually say none, okay? It's like it doesn't have a highest value, okay, that it reaches. So the amplitude would just be none. Okay? It goes on forever in the positive y direction and in the negative y direction. So we say it doesn't have an amplitude. Okay. All right, secant is going to be very similar. We're focused on the red secant graph, not on the black cosine graph. Go ahead and be completing these and see how you're doing with domain and range, x-intercepts, y-intercept, vertical asymptotes, period, and amplitude. Okay. All right, so we're focused on the red graph, not on the cosine graph. And so I can see that the domain is not going to be all reals because those dashed lines that I have, vertical lines, those are the vertical asymptotes. Those are gaps in the graph horizontally. There's no ordered pair there. And see, it happens at pi over 2 and 3 pi over 2 and 5 pi over 2. Okay. And so for the secant graph, the domain is going to be all possible x's except, let me do that in red down here, all possible x's except when I've got that pi over 2 thing, it can be a little harder to do, at pi over 2 plus or minus some multiple of pi. Okay, another way to write it is just pi over 2 plus n pi. So here's pi over 2. Every time I add pi, I'm going to get a vertical asymptote. Every time I subtract pi, I'm going to get a vertical asymptote. That's a way to handle it when you have an odd, when you want to say add some odd multiple. Okay. All right, now for range. For range, that looks a lot like the cosecant looked. See how it goes from negative infinity and gets to -1, but then we have to jump where we had the cosine graph until we get back to 1 and keep going. Okay, so that would be our range. Our x-intercepts, there aren't any. No, we're not looking at the black graph, we're looking at the red graph. It does have a y-intercept though. See how the y-intercept is at 1? Okay. Because the cosine has a y-intercept at 1. Okay, and that matches. All right, we had vertical asymptotes. Remember how that's related to domain? They happen at those vertical lines. Okay. So I'm here, I mean, x can't be this number. Here, I mean, x equals this. I mean this vertical line where x equals pi over 2 plus n pi. Okay. All right, now the period for this is also going to be 2 pi. Okay, you don't get the repeat until after you've done that, and this little piece. Then you can start just repeating, taking a picture of that and copying it. Amplitude, we would say there's none. Okay. All right. Now let's take a look at tangent. All right, the hardest thing sometimes is just being able to write when you have that repetitive nature, knowing how to say what you mean. Oops, I forgot vertical asymptotes. And there's a lot of those. Then period. This won't have an amplitude either, so I don't really even need to write it. Okay. All right, so for domain, you do have vertical asymptotes, so that means you do have gaps as you look from left to right. It's not a continuous function. And what you need to state is when those vertical asymptotes happen. So see how here you have one at pi over 2, and then for every pi after that, you have another one. See that? Okay, so your domain would be all x's except at pi over 2 plus or minus a multiple of pi. Okay. All right, now the range, see how it keeps going towards positive infinity and keeps going to negative infinity, and there's no gap up and down? The range is going to be all real numbers. Okay. All right, now for x-intercepts, you have an x-intercept at 0, at pi, at 2 pi, at negative pi. Remember that graph got slipped over a little bit, but that's where it actually hits. So your x-intercepts are going to be at n pi. Okay, some multiple of pi. N is an integer, so it can be 1 pi, 2 pi, or it could be -1 pi, -2 pi, or even 0 pi. Right, and the y-intercept is right there at 0. The vertical asymptotes are what's causing that domain to be all reals except. The vertical asymptotes are the vertical lines at those locations. Okay, so those kind of always match. All right, now let's think about the period of this one. You know, on all the other ones, we had to go a full 2 pi before we had enough information to be able to repeat, you know, to be able to get our picture to repeat. But you see how I really get enough information with just one chunk like that, just gets repeated over and over again. Or I could think of it like this together with that. You know, the whole thing happens within just pi. So the period isn't 2 pi, it's pi. Okay. So you can repeat what happens within 1 pi worth, and then that keeps going to the right and to the left. And then there is no, we don't talk about an amplitude because it just goes off to infinity and to negative infinity. All right, let's look at cotangent. Cotangent was kind of like tangent. It just looked like each of those pieces were sort of flipped over, you know, and then moved a little bit. So we're going to have similar feel to this situation. So go ahead and be filling these in, and then you can check yourself. And there's not going to be an amplitude. All right, so let's think about these then. So this is for cotangent. So the domain has the jumps in the graph. Okay, we have to exclude here at 0, at pi, at 2 pi. So everything except 0, pi, 2 pi, 3 pi, negative pi. So x can't be a multiple of pi. Okay, remember n is an integer. The range is from negative to positive infinity. X-intercepts happen at pi over 2, 3 pi over 2, 5 pi over 2. So the x-intercepts happen at pi over 2 plus or minus a multiple of pi. All this plus n pi business, that type of thing, that happens because these trig functions are periodic. Okay, so you keep repeating your x-intercepts in both directions. Okay, the y-intercept, there isn't one. There's a vertical asymptote there. Okay, vertical asymptotes, they're connected to domain. They are the vertical lines. X equals a multiple of pi. And then just like tangent, you get a complete picture within pi. Okay, so the period is pi, not 2 pi on that. Okay. All right, so go ahead and be looking at those graphs and thinking through them and kind of getting that information into this chart about the domain range, x-intercepts, y-intercept, and vertical asymptotes. Okay, also, I want you to come in and I want you to just really look at the graphs of sine and cosine, okay? Look at what's the same, what's different, how are they similar, okay? In what ways are they different? Do the same for the tangent and the cotangent graphs. You know, how do their basic looks seem similar? All right, what's different about them? Okay, so take a little time on 5 and 6. I'll let you do those two. All right, on 7, I want you to think about how did we graph cosecant? Kind of run through that again in your mind. Think about why that works. How is it useful? Why does it work? Okay, think about how the x-intercepts on one of them turns out to be the vertical asymptotes on the other. You know, why is that? Okay, think about how the highest point on the sine graph turns out to be where the lowest point on those little u's happen. Think about that and try to write up a little bit of that, okay? All right, so I'm going to stop the video here. You should do a little more work trying to flesh out your answers, you know, gather the data in number 4 and flesh out answers to 5, 6, and 7, okay? All right.